Yes. Sasika students, today we will learn a very important thing. We will learn, suppose this is a convex, let's say this is a concave mirror. Am I right? In this concave mirror, let's say this is a principal axis, right? On this principal axis, when the rays are coming from different direction, how they will be reflected, okay? The ray might originate from focus, in which direction it will go. The ray might come parallel to principal axis, in which direction it will go. The ray might originate from the C. What is C? C is the center of curvature, which is at the same distance from F as F is from the center of the mirror, that is pole. All right. Suppose this is the ray, you know, obviously this ray and this ray will behave in the same way, this ray and this ray. So students, then other case can be, suppose I am, a ray is coming, incident ray is coming here at the pole. In which direction it will go? Not only that, students, we also want to learn how all these rays obey laws of reflection. All right, students, this is really something important, and very less books talk about this, or honestly speaking. All right, before understanding all this, students, we need to have two concepts clear. One is laws of reflection. What is law of reflection? Imagine, students, we are having a plane surface. All right, plane surface, this end of surface is polished. So this is a reflecting surface, right? More the surface is polished, better reflection it will give. Am I right, students? Now, the first law of reflection says, let's say there is an incident ray, incident on point A. All right, on point A, on the polished surface, plane surface XY, you know, XY plane. It's not a straight line, it's a plane, XY plane. Point A, incident ray is incident. Now, in which direction it will go? And what is the angle of incidence? In case, students, you want to measure the angle of incidence from point A, draw a normal. Draw a normal to the plane XY. Am I right, students? Now, remember that, students, the angle of incidence is the angle between the incident ray and normal. All right. Let us say this angle is angle I, angle of incidence. This is angle of incidence. And this is point of incidence. Point of incidence A, angle of incidence I. Well, students, law of reflection, first law of reflection say, everything in this nature is law. Is obeying some law, and actually to understand these laws is to understand physics. More depth we understand these laws, more we love physics. So students, the law of reflection says if this is the incident ray, this will not be the reflected ray. This will not be the reflected ray, but rather this will be the reflected ray. What is the difference? Why not this one? Why not this one? Why not this one? Because if this is the reflected ray, students, see that the angle of reflection is this, which is bigger than angle of incidence. No way. The reflected ray, students, reflected rays, interesting things makes the same angle as the what? As the incident ray. So that means this angle is known as angle of reflection, represented by R, angle I. is equal to angle R. Is the first law of reflection. That is the angle made by incident ray with the normal, an angle be made by reflected ray. This is reflected ray with the normal. With the normal angle R are both equal. Beautiful. What is second law? Second law is, students, now you see both. Imagine that these are vectors. You can say incident ray and reflected ray are vectors. These two vectors and normal. Right now I'm drawing on the screen of the laptop. The screen of the laptop is a good example of a plane. So you see that, students, all these three, incident ray, the normal and reflected ray, all lie in the same plane. It's not possible that this head of this incident ray vector is here and the tail is not on the screen. Both tail and head, and this normal all on the same, all touching totally in length on the same plane, that is screen of my laptop. So this is two laws. Right. One is these two laws, and the third and the second point, very, very important point, students, you already know. Suppose this is a circle. What is that, students? Suppose this is a circle. In this circle, students, you know what is a tangent? The radius and the tangent. What did I say? The radius and the tangent both make what angle? This is radius, this is tangent. The radius may be in this direction also, students. Let's say this is tangent. Okay, let's say this is tangent. So many tangents. Tangents always touch the circle on how many points? Any student? Tangent touches the circle on how many points? Tangent touches the circle only at one distinct point. See, students, if I am going to draw the radius here, again 90 degree. If I'm going to draw the radius here, again 90 degree. If I'm going to draw the radius here, again 90 degree. Which 90 degree? I will just show you, students, this angle is 90. Angle between radius, all these are radius and all these are tangent T1, tangent T2, tangent T3, tangent T4. Radius and tangent always make an angle of 90 degree. It's also possible that it's not possible if this is radius and this is tangent. Then it is not a tangent. This is known as secant, because secant touches the circle on 2 points, 1 and 2, but tangent touches the circle on single point. These two concepts should be clear. Radius and tangent of a circle always makes 90 degree. And number 2, laws of reflection. Angle of incidence is equal to angle of reflection. And incident ray, normal and reflected ray, what is that? All lie in the same plane. After you have understood, you can answer any question regarding the ray diagram of mirrors. I am going to discuss ray diagram in case of spherical mirrors. Now, students, if it is painted from outside or it is shaded from outside, I know that this is a which mirror? Yes, baby. This is which mirror? This is concave mirror. All right. This is concave mirror. Students, this is the principal axis of the mirror. Let me go to draw. This is the principal axis of the mirror. Right. Now, students, you know very well that the distance of this point pole from, once again, the distance of pole from this point. F is the focal length, FP, and the distance FP is equal to distance CF. What is C? C is center of curvature. That means if I extend this, spherical mirror, there will be a hollow sphere. C will be the center of that sphere. All right, students. So C is the center of sphere. F is the point where all the rays parallel to principal axis will meet. Why? The question is why. See, very simple. Based upon whatever knowledge we have got, we will try to answer these questions. Now, students, see, if this is the inner portion of the sphere and this is the center of the sphere, then you can understand if I project a line from C, it is just like the radius. Am I right? And this line will be just like the tangent. Am I right? Now, students, very simple. This angle will be 90 degree, right? This is C, this C, and let's say this point L. CL will be like the radius, right? And this is the tangent. Suppose a ray is, starting from point C. Incident ray is starting from point C. Then I can say the incident ray is along the normal. This is the normal. This CL in this case is the normal because this is the surface. This X dash is the surface on which CL ray is incident. And CL ray is incident along the normal. It is just like that, students. If this is the plane mirror, on this plane mirror, along the normal, there is incident ray. Then where will be the reflected ray? Can anyone tell? Along the same point. All right. Why? Because if the incident ray is along the normal, what is the value of angle of incidence? No, but what is the value of angle of incidence? Incident rays along the IR. If the incident ray should be like this, then this would have been the angle. This would have been the angle. More angle is increasing. Am I right? Now, the angle of incidence is 0 if the incident ray and normal are matching. That means according to law of reflection, angle of reflection should also be 0. That means if the incident ray is along CL, the normal, the reflected ray will be just back tracing the same path. Back tracing the same path. Beautiful. We learned one thing. We already learned the ray diagram when the ray is emanating from C. When the ray is originating from C. All right. This is clear. Now, student, one more thing we want to study. What? Let us say the ray is parallel to the what? Ray is parallel to the principal axis. Are you getting my point? This is the incident ray, which is parallel to principal axis. This is your principal axis. When the ray is parallel to principal axis, how it will follow the laws of reflection? Again, now students, it will follow law of, where is the normal? The normal is C and this point. Am I right? This is the normal. Am I right? We can say this is the normal. Now, if this is the normal, what will be angle of incidence? Any student can tell. Angle made between the incident ray and the normal. This is angle of, tell me, this is angle of incidence. Then the same will be angle of reflection. Where it will be? Students, same angle. Draw one more angle. The angle of reflection see that it is passing through F. See, if it is here, if it is not passing through F, see that this angle is small. You can see law of reflection is not getting obeyed. If this angle is more, then also law of reflection is not getting obeyed. You see the ray must pass through F so that once again the law of incidence and the the angle of incidence and angle of reflection are same. Am I right? I is equal to R. So you need to have little sense to understand that why some students may be asking why CL is the normal. Because at this point on this curve, what is the tangent? This is the tangent. This is the tangent and the tangent. This is, I'm sorry, this is the, I can say this is the tangent because this curve is not drawn 100% perfect. This is the tangent. So this angle is 90 degree, right? This angle is also 90 degree. So on the plane, 90 degree is known as normal. So this is normal. So we understood whenever a ray is passing, is parallel to the principal axis, it will always pass through the focus. So you also know how the law of reflection has been obeyed. And also second law, incident ray, normal, and this is your reflected ray. All lie in the same plane. All right, students, we have done this also. Now I might ask you one more thing. All right, if the ray is originating from F, then in which direction it will go? This is ray is originating from focus. The object is at focus. Object is at focus, and one of the ray from starting from the object is coming in this direction. Now, in which direction it will go? If object is at focus, the ray is starting from focus, right? This is the incident ray, right? Now, incident ray is making what angle? How will you make the angle? The angle will be always made with the normal. What is the normal? The normal is the line joining C and this point, right? Then what is the incident angle? Incident angle is this now. And what is the reflected angle? It will be this. That means if this is the incident ray, this one, this will be the reflected ray. Beautiful, students. So you have drawn ray diagram from so many points. You have drawn ray diagram from C, from F, from so many places. All right, students, let us say the ray is coming from here and striking at the pole. Can anyone tell in which direction the ray will be diverted? Yes, anyone? Always measure the angle of incidence, then simply draw the angle of reflection equal to angle of incidence. Any student? Correct. Yes, you please speak. So this incident ray is making what angle with the normal? And what is a normal? Now CP is the normal. Now CP is the normal. Why? Because this is center point of mirror. And in this case, the tangent will be like this. Am I right, students? Tangent will be like this, and the line normal to tangent will be CP. Am I right? That means incident ray will make, this is the angle of incidence, and same will be the angle of reflection. Wow, students. So the ray will get reflected in this direction, right, students? This will be angle of reflection. Remember, students, these ray diagrams are very, very important. when you want to study where will be the image, where will be the image in case of all the, all the cases. All right, students, let's take one more example. All right. The example is, students, let me extend this. Let me extend this one also. This is your, okay. Imagine, students, if this is the incident ray. This is the incident ray. In which direction it will be? It will go back. Anyone? Yes? Same direction? ऊपर जाएगी. Tell me. This is C. This point is C. Incident ray is touching the C and coming here. In which direction it will go back? See, draw the normal again. Draw the normal. See, student, this is the normal. Sorry, this is the tangent. Normal is same. Normal is same. So incident angle is 0. Reflected angle will also be 0. That means in the same direction, the ray will be, come on students, the ray will be, come on, reflected. Students, we have seen all the cases, how the ray will be reflected in case of concave mirror. Am I right? Now, students, we will take the case of, come on, we will take the case of convex mirror. All right, let us see. In case of convex mirror, what is happening? This is convex mirror which is bulging from outside. The reflecting face is bulging outside, and the face which is going inside is shaded. Am I right, students? Now, R is going to be going over there. Just see that, students, this is the principal axis. What is this? This is the principal. Come on, student, this is the principal axis. All right. This is a case of convex mirror. Let me write here. This is convex mirror. All right. In case of convex mirror, students, again, now, in case of convex mirror, the focus is on this side and C will be also on this side. Why? First, why? Why in case of convex mirror, the focus is on right side? Because when you extend this, students, just see, when you extend this, the circle will be, the sphere will be in this direction. And the center of that sphere is always center of curvature. Center of curvature. All right. Center of sphere is center of curvature. So F and C both will be on the right side. Am I right, students? Yes. Is it clear? Explained properly? This will be on the right side. All right. This is our C, center of curvature. This is our, principal focus because it is on principal axis. This is our pole, and we know that for sphere of small aperture, PF is equal to FC. Okay. Now, students, let us say some ray is coming in this direction. In this direction, some ray is coming parallel to principal axis. The ray is coming parallel to, if a ray is coming parallel to principal axis, a ray is coming parallel to principal axis. Now, what is the angle of reflection? Angle of reflection, if you want to see, students, then always join what? You will join C this. This is your normal. Always this is the normal. Why this is the normal? Because we know that this is the tangent. Is it right? Is it right? And the line perpendicular to tangent is the normal. So this is the normal. This is the normal. Now what will be the angle of incidence? Can any student tell? Angle of incidence will be this angle. All right. If angle of incidence is this, What is this? Is the incident ray. Then where will be reflected ray? Same angle you draw, students, and you will get a ray. You will get a ray, you'll get a ray. All right. And this will be, students, this, I'll tell you one thing, this ray must pass through the focus. This must pass through the focus. One second. Yes, this will pass through the focus. If it is extended. If it is extended, students, one thing I want to tell you, that this ray should not be drawn smooth. This should be shaded. This should be, a line like this. Why? It shows that this line is extended, right? So this line is also extended. It should be drawn like this, because actually the ray is coming in this direction. In this direction, it will get reflected ray. Or if this is the incident ray, right, students, then this will be angle of incidence. Then this will become angle of reflection, because in this convex mirror, the ray is not going to enter the other side. On this surface only it will get reflected. Am I right? So that means we have understood. All right, this we have understood. Now comes second thing, students. If the ray is coming in this direction, this is the direction of the ray. Okay, students, this is the direction of the ray. Then, student, what will be the direction of reflected ray? Can anyone tell? See, now in this direction, this is also normal. It's making 0 degree with the normal. So the direction of reflected ray will be same. This is incident ray and this is reflected ray. Am I right, students? Okay, one more thing. Now, suppose the ray is coming in this direction, then it will be reflected in this direction. Why? Because very simple, student, this is angle of incidence and this is angle of reflection. Students, hope you like the video, but I must tell you, before going to image formation, you must see this video again. If you like the video, do subscribe our channel and share with your friends. Thank you very much.